Welcome back, 8th grade. Today we are going to be doing a little bit of reviewing from what we did last time with our slope-intercept form equations and identifying the different parts of the equations. And then today we are going to move on into putting these slope-intercept form equations into a word problem and then solving them. But we were going to read through the problems together. Don't worry, we're going to identify our keywords and simplify this as much as possible. But first I'm going to hand out the note sheet for today. As always, we're going to start with a quick review of last time, starting off with the vocabulary that we went over last class. So we're going to need this for the word problems. It's just an extension on what we've been doing. So first, we're going to review what the slope means. Does anybody know what the slope means? Yeah, the slope is a number that describes the directions and the steepness of a line. So when we were looking at the graphs, that's how we went over and then up. That's how we determined our slope. The y-intercept. This was the point where the line passed through the y-axis. Whatever point on that y-axis that the line crossed through, that was our y-intercept. Then when looking at the different coordinates, the x-coordinate was when we had our ordered pairs. It was the first element in our ordered pair. And then same thing, the y-coordinate, that was the second element in our ordered pair. So the x-coordinate was where we were on our x-axis, the one that goes horizontal like this. However many we were over, whether it was in the positive direction or the negative direction, that is going to be our first element in our ordered pair. And the y-coordinate, same thing, just whatever we went in the vertical direction. Again, it could be positive, negative, wherever we were at. And then finally, the big thing is putting all of these terms together into slope-intercept form. So slope-intercept form is when we have an equation in y equals mx plus b, where y is going to be our y-coordinate, which is our output. X is the x-coordinate, which is our input. And then m is the slope of the line, and b is the y-intercept. So to review, we are going to look at a few of these equations in slope-intercept form, and we're gonna just identify the different parts, pieces, just to make sure we're good on all that before we move on to doing some word problems. So we're gonna identify the slope and the y-intercept in the following equations we have on our sheet here. So for the first one, we have y equals 5x plus 4. Can anybody tell us what the slope of this line is? Yes, the slope is 5. Since it is linked with our input value, that will be the slope of the line. That's how you can tell. Can anybody tell us what the y-intercept is? Yes, it is 4. Because the line, we have a line going with a steepness of 5x, and then we moved it up 4. So it is going through the y-axis at 4. Very good. All right, so our second equation is y equals 10x plus 7. Can anybody tell us what the slope of this line is? Correct, it is negative 10. So that means that we are moving down in steepness at a level of 10. And then where does this line cross through the y-axis? So what is our y-intercept? Yes, it is 7. So it's a line with a steepness of negative 10, moved up 7. All right, the last one is still in slope-intercept form. It is y equals 3 minus 9x. We can see these equations switched around because of our addition and subtraction properties. This would also be the same as y equals negative x plus 3, as we have looked at before. So don't let this confuse you, but what is the slope of this line? Yes, it is -9, because -9 is the coefficient to the x value, the input. And where is the y-intercept for this line? Right, it's at 3. All right, so it looks like we're doing very good with identifying the different parts of our equations. So we're going to move on and start looking at what we're going to be going over today, which is the word problems. So the first go over these slope-intercept word problems. There's different steps we're going to take when first starting these. They do involve reading and some comprehension skills, so we are going to I'm going to walk through these with you guys, and we're going to just like identify the different keywords and stuff, and we're going to get through them. So when first looking at a word problem, we want to take the following steps. So first, we're just going to read through the problem just to get a first look at it, and then we'll go back through. So then you're going to want to go back through a second time and just identify what the problem is going to ask us. Usually it's at the beginning or the end, but sometimes they sneak it in somewhere. So we're just going to identify what the problem wants us to do. Then last, we're going to interpret the problem, and then we're going to translate it into an equation or something that we can use to solve this problem. So when looking at slope-intercept form word problems, there's a lot of keywords that we're going to look through, and you're going to see them when we start reading these problems, but, just to start going through them. So for finding the slope, there's a lot of times you're going to see words like per hour, makes, like they make this much money, per minute, every month. Just different words like per is used a lot, every, each, words like that like identify like things that are increasing or decreasing in value, because the slope isn't just a steady value. Like when you're putting in the inputs, like you're gonna have it moving. And then for finding the y-intercept in these word problems, it's going to just be a solid value. The y-intercept isn't going to change. It's always going to be the same. So we're going to have words such as had, initially, starts off with, already made, things like that, that show that this value is set in stone and it's going to be the one we're using. So looking at our first example, we're going to read through this together and then identify our keywords and go through the different steps to put together the equation. So Johnny is selling water bottles at a concession stand. The concession stand has $30 in the register when Johnny arrives. Johnny gets $2 per water bottle he sells. So write an equation in slope-intercept form to determine the amount of money the register will have in it based on how many water bottles are sold. All right, so that was our initial read through the problem. So now we're going to go back and look through for our what the problem's asking us. And as you can see, the last sentence, write an equation in slope-intercept form. So that's what, it just straight up says that, so that's what we're going to do. Now we're going to interpret what the problem's context is and translate it into our equation. So it says the concession stand has $30 in the register when Johnny arrives. So as you can see, our keyword has, it's saying that $30 is already there when Johnny gets there. So that is our set value. That is our initial starting point. Johnny gets $2 per water bottle he sells. So the key word in this sentence is per. So every time he's going to sell a water bottle, he's going to get $2 that he can add to the register. So we can identify that as our slope. That is going to be what our input is going to be multiplied to determine. So putting this all together, our equation, we're going to do y equals, because y is going to be our output, and that's what we're going to start with. And then since we identified 2 as our slope of the line, that is going to be the coefficient for the x. So we're going to have 2x, and then plus 30, since we already had 30 there. So you can use that equation, plug in any x value, and x would mean the number of water bottles that he sold. So you can plug in any x value into that equation and then determine the y value, which would be how much money you have in the register. All right, so moving forward to our next problem. Beth makes $10 an hour at her job at the shoe store. She wants to save up $400 to buy herself a new cell phone. There is already $150 in her bank account. Write an equation in slope-intercept form and use it to determine if Beth worked 20 hours, would she have enough to buy the phone? So that was our initial read-through. So now we want to go back and look what the problem is asking us. And as you can see, we have a question in here. So there's two things that this wants us to do. Write an equation in slope-intercept form. So we can do that, just like we did in the last problem. And then now this one wants us to use it in context of the problem. We're going to use what equation we write to determine if Beth worked 20 hours, which means we're going to plug X in. That is going to be our input value. Would she have enough to buy the phone? So then based on the output value, we'll see if it's more than 400, less than 400, equaling 400, and then that'll help us determine if she can afford this new phone. So now we're going to go back through and use our keywords to help us find the equation. So the first sentence, Beth makes $10 an hour at her job. $10 an hour. So we can see that that is going to be her changing, the changing point. So that is going to be our, slope of the line. She wants to save up $400 to buy herself a new phone. In the context of this problem, this is what we are going to compare our output to. So as we can see, there's really no keywords that lead us to believe that this is going to be our y-intercept. So we're just going to keep going through. There is already $150 in her bank account. That's the value that we want to use as our y-intercept. That's going to be our b value because that's what she already has, not what she needs. So putting this all together into our slope-intercept form equation, we're going to use y because that's going to be our output value, equals, then our slope we found to be 10. So 10x, because 10 is our coefficient to the x, plus $150 that she already has. We determined that to be our b value. All right, so now that we have it in slope-intercept form, we're going to use this to determine if Beth worked 20 hours, would she have enough to buy the new phone? So we already wrote the equation. $20, that is my bad. 20 hours, that is going to be our input value. So we're going to input $20 hours into our equation. So y equals 10 times the 20 hours plus 150. So now everybody plug that in to your calculators and see what our output gets. 350. All right, so now we're going to take our output. She worked 20 hours, making $10 an hour, already had $150. Now she has $350. Does she have enough to buy a $400 cell phone? No, because $350 is less than $400. So Beth does not have enough money to buy her new cell phone just yet. All right, really good. So now moving on to our last example before we are playing bingo. Olivia wants to start subscribing to a movie renting service. The initial cost to join is $80, but once you are joined, each movie only costs $3 to rent. Write an equation in slope-intercept form to represent this scenario. If Olivia rents 12 movies, how much would have she spent on movies? So that was our initial read. So now we're going to go back through like we've been doing and find what the problem is asking us. So as we can see in the last two sentences of this question, it wants us to write an equation in slope-intercept form representing this scenario. And then another follow-up question is, if Olivia rents 12 movies, how much would have she spent on the movies? So first we're going to answer the first part, which is writing an equation in slope-intercept form. So we're going to go back and look for our keywords. First we have the initial cost to join is $80. Initial is our big keyword here because that's just set in stone. That's what it's going to cost without even buying a single movie. And then once you're already joined, each movie costs $30. Each movie only costs $3 to rent. So our big keyword here is each movie. So depending on the number of movies, you're going to be renting $3 per movie. So that's how we can tell what our slope is. So now we determine 80 to be our B value, our y-intercept, and 3 to be our M value, our slope. We can put this all together into the equation. So y equals our output equals our slope, which we found to be 3x times our input, plus 80, which we found to be our B value. So using this in terms of this problem, Olivia is renting 12 movies. She wants to find out how much she spent on her on movies overall. So we're going to plug our 12 into our equation because our input is representing how many movies that Olivia actually rented. And we're going to plug this 12 in and then get our output of how much the movies cost. So we do y equals, which y is going to end up being our output, 3 times 12 plus 80. So now everyone's going to plug this in or figure this out. And how much does Olivia spend on movies? Right, $116. All right, so now that we have our keywords and we've looked through some problems, we're going to try doing some on our own. And we have a fun little activity plan. We're going to play bingo, which is usually a big hit. So I'm going to pass you guys out a handout. And then on the smartboard, I'm going to project the different problems. And we're going to work through these problems presented to you guys. And you're going to identify, go through the steps that we've just been going through and identify your correct answer. And then you're going to have your bingo card. And we're going to, when you find the right answer on your card, you can put a chip there. And once we have a solved bingo card, our winners will receive a prize. So now we're going to move on to that activity.